A number is a mathematical object used to count and measure. Look at the apples and count 1, 2, 3, 4, and 5. The real numbers are the set of all numbers which contains both rational numbers and irrational numbers. Look at the flowchart. Real numbers are divided into two categories: rational numbers and irrational numbers. The rational numbers are further divided into two categories. Finally, integers are divided as the negative numbers and the whole numbers. All of these numbers are given with some examples. You can carefully observe them. After completing this content, students will be able to understand the Euclid's division lemma, to understand the difference between Euclid's division lemma and Euclid's division algorithm, be able to find out the HCF of two given numbers by using Euclid's algorithm, be able to find out the HCF and LCM using prime factorization, be able to define rational numbers on the basis of their decimal expansions, be able to segregate rational numbers from irrational numbers on the basis of their decimal expansions. Euclid's division lemma states that for any two positive integers, a and b, we can find two whole numbers, q and r, such that a is equal to b times q plus r. Let us understand this lemma through an example. Show that every positive even integer is of the form 2 times q, and that every positive odd integer is of the form 2 times q plus 1, where q is some integer. Solution. Let a be any positive integer and b equal to 2. By Euclid's division lemma, there exist integers q and r such that a is equal to b times q plus r, where the value of r is greater than or equal to 0 and less than 2. This implies either r is 0 or 1 because r is an integer. Therefore, from a is equal to b times q plus r, we get a equal to 2q or a equal to 2q plus 1. If a is equal to 2q, then a is an even integer, as it is a multiple of 2. Euclid's division algorithm. An algorithm represents a series of well-defined steps which provides a procedure for solving a type of problem. Euclid's division algorithm is a technique used to compute highest common factor or HCF of two given positive integers. The HCF of two positive integers a and b is the largest positive integer d that divides both a and b. Steps to obtain the HCF of two positive integers a and b, where a is greater than b, are given below. Step 1. Apply Euclid's division lemma to a and b. We find whole numbers q and r such that a equal to b q plus r, where the value of r is greater than 0 and is less than b. Step 2. If r is equal to 0, b is the HCF of a and b. Step 3. If r is not equal to 0, apply Euclid's division lemma to b and r. Step 4. Continue this process till the remainder is 0. The divisor at this stage will be the required HCF f. Let's see this in the form of a flowchart. The fundamental theorem of arithmetic. Fundamental theorem of arithmetic states that every composite number can be expressed or factorized as a product of prime numbers, and this factorization is unique except in the order of the prime factors. Let us take any composite number and factorize it. For example, 156. Let us see what we get if we start dividing 156 by other prime number 2. Now, start dividing by other prime number 3. In both cases, the prime numbers are same, only the order in which they appear is different. You can have a look at the factors. Example 2. Express 9720 as product of primes. Solution. When 9720 is divided by 2, we get 4860, which is also divisible by 2, and after dividing we get 2430, which is also divisible by 2. And now, going on further with this process, we get 1. Therefore, its factors are 2 cube times 3 raised to the power 5 times 5. Example 3. Find the HCF and LCM of 336 and 54 by prime factorization method. Solution. When 336 is divided by 3, we get 112. Now, 112 is divisible by 2, which gives us 56. Continuing this process further, we get 1. So, the factors of 336 are 2 raised to the power 4 times 3 times 7. When 54 is divided by 2, we get 27, which is divisible by 3 and gives us 9. Continuing this process further, we get 1. So, the factors of 54 are 2 times 3 cube. Now, HCF of 336 and 54 is given by the product of the minimum powers of each common prime factor, that is 2 times 3, which gives us 6. Now, LCM of 336 and 54 is given by the product of maximum powers of each prime factor involved in the numbers, that is 2 raised to the power 4 times 3 raised to the power 3 times 7 raised to the power 1, which gives 3024. If a number x cannot be written in the form p over q, where p and q are integers, and q is not equal to 0, then that number is known as irrational number. For example, square root 2, square root 3, square root 5 are irrational numbers. Theorem 1. Let r be a prime number. If r divides a square, then r divides a, where a is a positive integer. Let us understand it with the help of an example. Prove that 3 plus 2 times square root of 5 is irrational. Solution. Let us suppose the given number is a rational number. This implies we can write it in p over q form, that is, in lowest form, where p, q are integers and q is not equal to 0. Rearranging the terms and solving it, we get p minus 3q. 2q are integers. This implies that p minus 3q over 2q is a rational number. This also implies that square root of 5 is a rational number, as it is equal to that ratio, which contradicts that square root 5 is an irrational number. Therefore, our supposition is wrong. Hence, the given number is an irrational number. Theorem: consider S be a rational number whose decimal expansion terminates. Then S can be expressed in the form P over Q, where P and Q are co-primes and the prime factorization of Q is of the form 2 raised to the power n times 5 raised to the power m, where n, m are non-negative integers. Examples: convert the given rational numbers in the decimal expansion form. To solve these questions, we have to make the denominator as 10 or in the form of powers of 10. Let's see how it is done here. Theorem: consider S equal to P over Q be a rational number such that the prime factorization of Q is not of the form 2 raised to the power n times 5 raised to the power m, where n and m are non-negative integers. Then S has a decimal representation which is non-terminating, that is, repeating. Examples: check whether the given numbers are in the terminating or non-terminating form. First, 35 over 50. The denominator of this rational number has only 2 and 5 as prime factors. Hence, it has terminating decimal expansion. Second, 51 over 24. The denominator of this rational number has only 2 as prime factor. Hence, it is a terminating decimal. Let us summarize what we have learnt in this module. Euclid's division algorithm is a technique used to compute highest common factor of two given positive integers. HCF of two positive integers a and b is the largest positive integer d that divides both a and b. Fundamental theorem of arithmetic states that every composite number can be expressed or factorized as a product of prime numbers, and this factorization is unique except in the order of the prime factors. If p over q is a rational number such that the prime factorization of q is not of the form 2 raised to the power n times 5 raised to the power m, where a and b are positive integers, then the decimal expansion of the rational number p over q does not terminate and is recurring.